Daniel's tasked with the promotion and communication of the world-class research happening at the SAAO. Let's hear it for a science astronomer, Daniel Cunnama.
Thank you for the introduction. As has been mentioned, my name is Daniel, and I am an astronomer. I am based at the South African Astronomical Observatory. Our head office is in Cape Town, South Africa, and we've had an observatory there for over 200 years. We celebrated our 200-year anniversary in 2020. But these days, and for the last 50 years or so, all of our telescopes are up in Sutherland. It's in the Northern Cape. It's about a 4-hour drive from Cape Town. And the reason we have it there is because we really want to get away from people. We like people. We really like people. Just not at night. Because people bring light. And what we want as astronomers is to see beautiful night skies with no light pollution. So no cars, no houses, nothing nearby, so we can really see the best of our country and the best of our stars. So who am I quickly? How did I get here? I am an astronomer. I did my PhD. First, I studied maths and science at school, and I had a real curiosity. I always wanted to know how things worked, not just astronomy. I really wanted to know how absolutely everything worked, and my dad really got irritated with me asking why all the time. But then I did my first degree in physics and maths at the University of KZN in Pietermaritzburg, and I moved down to Cape Town to the University of the Western Cape in Bellville to do my PhD, and from there I became an astronomer. So I talked already about the dark skies, and this is one of the things which South Africa has, which many places in the world do not. And South Africa, because of that, and for a couple of other reasons, is one of the best places in the world to be an astronomer. We really have incredible dark skies. The Sutherland Observatory in the Northern Cape is the third best professional observatory for dark skies in the world. So we really are right up there in terms of our resources, and we also have an incredible amount of support. So the government, over the last 30 years, has poured a huge amount of money and energy and support into making astronomy an incredible science and a strength of South Africa. We've gone from having less than 10 astronomers in the country to over 450, just in the space of 30 years, and I tell you, we need more. We really, really need more, and I'll tell you why in a moment. So, with this support, the first thing that came along was this, the Southern African Large Telescope. So this is our observatory up in Sutherland, and you can see the stars up there are absolutely amazing. There's very little light pollution, and we have this huge telescope and a whole lot of other telescopes of smaller sizes. This telescope, as you can see, is about 6 stories tall. It's the 4th largest optical telescope, and that means it has a mirror and it sees visible light. The 4th largest optical telescope in the world and the largest in the Southern Hemisphere. Inside that is a mirror which is 11 meters across. So it's made up of 91 1-meter mirrors and has a big circular mirror of 11 meters across. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I was scared I was going to run out. So that's how big the mirror is. So you can imagine what we can see. We can see the most distant galaxies. If we pointed it at the moon, we'd be able to read the back of a 2-rand coin. It's an incredible instrument. And this is a South African instrument. It was built by South Africa for South Africans. It was completed in 2005. And all of South African researchers have access to using SALT. So that is one of the amazing things that we have at our disposal, and all of our students are able to use it for free. The other thing, which is equally exciting, is the Meerkat Radio Telescope. So this is also in the Northern Cape, but this is a slightly different telescope. So these dishes are 15 meters across. I won't step it out, but it's bigger than the stage. And there are 64 of them spread out over the Karoo. So this is even further away from people. We like to joke that, the optical astronomers, we like people. They can come see our telescopes in the day. The radio telescopes don't want anyone there ever. So the radio telescopes can work 24/7, which means it doesn't matter if it's day or night. They don't want people around. And radio telescopes work in a slightly different wavelength. So you guys might know about the electromagnetic spectrum. What you can see with your eye and what SALT can see is visible light. So we can see all the colors of the rainbow, but light comes in many, many wavelengths, most of which we can't see. X-rays, gamma rays, microwaves, this is all light. And radio waves is a form of light. And when we're astronomers, what we want to do is collect as much light as possible so that we can learn as much as possible about the universe. So we build these huge radio telescopes. We build them very far away from people with phones, TV, radio, anything that's going to make noise in the radio wavelengths. So we have this incredible telescope, again, a South African invention, the most powerful radio telescope in the world, completed in 2018. And now, additional to that, there's going to be another 130 dishes for the square kilometer array, which is coming in the next 5 years. So South Africa is the place to be when it comes to astronomy. And we are desperate for people to get involved. We're desperate for students, we're desperate for more and more researchers, and we're desperate for data scientists. So one of the things which you can imagine is having these huge telescopes, we collect a lot of data. The SKA, when it comes online, will produce more data in one day than the entire internet thus far. So we have to deal with that, and we have to have some cybersecurity around it, but we have a lot of data to process. And that's one of the big challenges and one of the things we're doing here in this country. We've got some of the most powerful supercomputers in the world too, to try and prepare for this. But I wanted to talk to you a little bit about what we do on a day-to-day. So there are two types of astronomer. There's astronomers who work in the day and astronomers who work at night. We alternate between the two, so we don't get to do just one or the other. But in terms of what we do on a daily basis is, as an astronomer, we need to monitor our telescopes. So we need to make sure all the equipment's working properly. We need to provide upgrades, not just to the technical equipment, but also to software. We collect this data and analyze it. So we make plots. We try and work out what's going on in this distant galaxy or with this star, which just seems to be exploding. And then we work with collaborators. So astronomy is a beautiful science. We don't work in competition with anyone else. Everyone is just trying to push astronomy forward. So we have collaborations with people all over the world. We work with NASA, we work with all these universities, Oxford, Cambridge, everywhere else, all trying to solve these huge problems of where the universe came from, where did the Earth come from, and how is the universe sort of working and forming and evolving. In terms of the nighttime operations, that is a little bit more tricky, and we have these observing stations. We don't necessarily even have to go to the telescopes anymore. This one is in SALT. You can see SALT is getting controlled there. We have to monitor the weather. We have to monitor the positions of the mirrors and the telescope, make sure that everything's operating perfectly, and then take our observations. So it's an incredibly technical and constant struggle to try and make sure everything's operational. And then we get to make our discoveries. So we find these incredible things. We get to look at distant galaxies. We get notifications for things which have exploded, supernova, and we try and get our telescope to it as fast as possible to try and get an observation, try and work out what it was. So we, as I said, we are in an incredibly lucky place in South Africa We have incredible resources, incredible support from the government and the rest of the world. There's a huge amount of energy and money getting poured into astronomy right now, and we are really at the forefront of astronomical research. So it's an incredibly fascinating field, and I think so at least. We have incredible resources, incredible instruments, some of the best telescopes in the world available to us. And the possibilities going forward and for discovery are absolutely limitless. It's a very exciting field. And if you want to find out more, visit our website. It's nice and simple, saao.ac.za. You can also find us on social media, Instagram, Facebook, Twitter, or X. And yeah, we'll keep you up to date with what's going on and the opportunities. Thank you very much.
Thank you so much for that illuminating presentation. You get it? Illuminating, because you're doing this stuff. Okay, someone got it. Someone thought it was funny.
We're here all night.
I'm trying, guys, I'm trying. Okay, does anybody have any questions for him? This is a really cool field. I saw a bit of a hand over there, but I feel like everybody... I saw that hand.
At the back.
Was that a hand? Okay, we're bringing a mic to you. Please put your hand up again.
She's too shy.
Too shy? Okay, it's
That's
just you and I. It's just you and I. Don't worry about them in the room. Or ask your friend to ask the question for you. Can you tell? No?
Oh, I love questions. Come. Something, anything.
Just whisper to me.
Ask me about a black hole.
No? Nothing at all. Okay, we tried. I think our students are a little bit nervous on that side of the room, but we have a question over here.
Yes.
It's on, don't worry.
Hello.
Hello.
I am Busisiwe and I'm from Kahobocha. Well, there's something that I don't understand. It's space. In space, it's dark, but there's sun.
Yes.
Why?
Great question. Okay. So today, right now, if we look outside, you can't see the stars. Why? The sun is up, okay? And the sun is our star. So it's our closest star, and we are so close to it that it is incredibly bright. I can't get back to my slides. But when you look at our star from so close, it's so bright that we can't see any of the other stars. At night, when the Earth has spun and we're looking the other way, so when we're looking away and our sun is in the shade, we're in the shade, now we can see all of the other stars. Like this, right? So now at night, you can see all of these other stars. They're all just like our sun. This here is like the disk of our Milky Way galaxy. So our galaxy is made up of billions of suns, 100 billion suns, and all of them are kind of spread through the night sky. And that's what we can see when we look out and see other stars. But they're all suns just like ours. The problem is, for us optical astronomers, is the sun is too bright to see anything else when he's up. I hope that answers your question.
We have a question over here.
Yo.
You see, now they're asking questions.
now
You
we
just
go.
needed the first question.
Yeah. We'll be here all afternoon.
So my name is Rokhrijani, and I am interested in astronomers. So I wanted to ask you, sir, last time I saw stars forming a line and moving. So what kind of cause that causes those stars to move?
Okay, so if you see, if you look out in the night sky, right, the stars move slowly over the night, over the course of the night, in the same way as the sun does, and that's actually because the Earth is rotating. So the sun rises in the east and sets in the west, and all that is the Earth rotating. So the stars will all rise in the east and set in the west too. What you might have seen, and what you can see if you go out this evening, in the first hour or two after sunset, you'll see these lights moving across the night sky, often. There are quite a few of them. And what those are satellites. So people are putting more and more satellites up in space. They do various things. They send internet, they send DSTV, they send all sorts of messages up and down to space. And they have solar panels on them, which reflect the sun's light just after sunset or just before sunrise. And that's probably what you've seen moving across the sky.
Okay, we're going to ask 2 more questions. There's one over...
Which side do you
There's
wanna
one
go
on
first?
this side, and then one on that side of
Should
the
we go
room.
there?
And then
Which
we
side
need
we
to
going
get to
first?
our next speaker. So who was first?
That's it.
Was it him? Okay, you'll be the last one.
Okay.
This one.
How, guys, stop fighting. Remember, we
Rock,
said
paper,
in
scissors.
astronomy, they're not fighting against each other. They're all pushing forward.
collaborate.
So let's work together and collaborate. Do you want to let him go first, and then you can be last?
To go first.
You can have the last say. Come on, relax.
My name is Tatu. Yeah, Tatu Mugayani. I come from Ntsuphepa Primary School. I wanna know, sir, what is your favorite planet and why?
My favorite planet isn't a planet anymore. My favorite planet is now a dwarf planet. And that's Pluto. Do you
Why?
know the story of Pluto?
Tell us.
When I grew up, how many planets are there? How many planets are there?
Hey, I'm hearing different
Eight.
numbers, hey?
When I grew up, there were 9. And then all the astronomers got together in a collaboration and decided that Pluto wasn't a planet anymore. We decided it's too small. Now he's a dwarf planet. So that's my favorite dwarf planet.
Okay, thank you for telling us.
Sure.
Now you can ask your question, sir.
Oh, looking forward to it.
How are you?
I'm great.
My name is Nkosana from Sakubucha Kaubucha, and I'm also interested in dark holes. Do you know a black hole?
Yes.
Yes, I want
Black
to know how
holes.
black holes occur. That's what I'm interested in at the moment.
It's a great question.
Thank you.
Black holes are something which is very, very interesting. And I need something to throw, but I can't.
Here's my shoe. Here.
No, not your shoe. Okay, I'll throw your shoe. You hold that. Okay, so we need to talk a little bit about gravity. Okay? We know about gravity. Throw something up, comes back down. Okay? That's because the Earth has mass and it's pulling this back down. Okay, I won't need it again.
Thank you.
But if you have enough gravity, so a star is much more massive than the Earth, so it has much more gravity. It's harder for things to escape. If you have something with so much mass, you have to go faster than the speed of light. So I have to throw that shoe faster than the speed of light for it to escape a black hole. And that's why it's called a black hole. So you throw that light up, it bends over, just like the shoe, falls back down into the black hole. So it's an object which is so massive that the gravity is so strong that nothing can escape it, not even light.